In today's artificial intelligence class, we will see the information retrieval system from third unit. Okay, in today's class, we will discuss the basic information retrieval system. After that, the characteristics of IR, and next the model called as Boolean keyword model and the drawback of this Boolean keyword model. So after that, some of advanced models are there for information retrieval. We will see all those things one by one, that is IR scoring function, IR system evaluation, IR refinement, the PageRank algorithm, hits algorithm and question answering model. So all those things we will see one by one. Information retrieval, which is otherwise called as IR. IR is a software program which is used for accessing and retrieving the most appropriate information from document repositories. Repository means dataset. Dataset or database. Okay, this database contains the textual information. Textual informations are unstructured data. Unstructured data which are the language used for this textual information are the natural language. Okay, so the repository contains the natural language documents. Okay, and by using some query, the query will be given by user, and by using this query the required information will be retrieved from these repositories. Okay, and for information retrieval we can use the context based indexing or metadata. Okay, and this is called as information retrieval. Information retrieval means we are going to retrieve the information from document repositories, and this repository contains the textual information which are unstructured by using the query. Query will be given by users. Okay, and this IR system produces the existence and location of documents. That means in which place the document is located in the depository, and which consists the required information which satisfies the user requirement. Okay, so based on the query which are given by the user, the exact data will be retrieved from the document repository or from the database. Okay, and data should be satisfied by the user. For example, we can take the Google search. Okay, from Google search, in the text box we can type the required information which is otherwise called as keywords, and these keywords will be acted as a query here. Okay, from huge collection of the data repository, the query will retrieve the required information given by the user. Right, here the IR system searches the collection of natural language documents with the goal of retrieving exactly the same set of document which the user required. Right, and they have their origin in library system. Basic IR system. This diagram explains the basic information retrieval system. Here the first one is indexing the collection of documents. Okay, all the documents are stored in the database or repository, and the document should be indexed properly. And second one, transforming the query in the same way as the document content is represented. Okay, so based on the content of document, how it will be represented in the database, accordingly the query should be designed. Okay, then only we can retrieve the required information from the database. That is, the query representation and document representation should be equal. And the third one is comparing the description of each document with that of the query. Okay, so based on the query, that data will be compared in the document. So which document suits for this particular query, that document will be retrieved from the data repository. Okay, so for this we can use this matching function. After that, listing the result in order of relevancy. Okay, So the result will be displayed here. The characteristics of IR system. The first one is a corpus of document. A corpus of document means a body of document, otherwise. Body of document. How the document will be stored in the information retrieval system? It may be either a paragraph or a page or a multi-page text. Okay, normally this is unstructured data, okay, by using the natural languages. And second one is queries posed in query language, right? That means a query which specifies what the user wants to know. Okay, so by using the query only, the user will retrieve the required information from the data repository. Okay, the query language can be just a list of words. Okay, list of words or list of keywords. Okay, and the third one is a result set. Result set means this is a subset of document that the IR system judges to be relevant to the query. So from the entire repository, it will take the data which are relevant to the query. So that will be displayed in the result set. Okay, this is the third one. And the next one is a presentation of result set. How the result will be presented. Okay, and this can be as simple as a ranked list of document titles. Okay, very simple one is ranked list of document titles. Suppose if it is very complicated means a 3D model, that is the 3D colored model will be displayed on 2D screen. Okay, Boolean keyword model. So the earliest IR system worked on this Boolean keyword model. Here each word in the document treated as a Boolean feature. That means if the document is true, then the given word is occurred in the document, otherwise it will give false. Okay, so each word in the document which is treated as a Boolean feature. Okay, if the word is present, then the result will be true, otherwise the result will be false, right? The query language is the language of Boolean expression over features, right? And the document is relevant only if the expression evaluates to true, otherwise the document will be irrelevant, right? The disadvantage of Boolean keyword model. Though the Boolean keyword model is very simple and very straightforward, and it is also having some drawbacks. The first one is the degree of relevance of document is a single bit. Okay, only one bit relevance is associated to the document, either true or false. Okay, so there is no guidance to how to order the relevant document for representation. Okay, that means the indexing is very difficult here. Okay, because of only a single bit. And the second one is the Boolean expressions are unfamiliar to users who are not programmers or logicians. Okay, so only the programmers can understand the Boolean expressions. The normal non-programmers or the end users may not know how to use the query to retrieve the data if it is formed in Boolean keyword model. And when come to third one, it can be hard to formulate an appropriate query even for skilled user. Okay, sometimes the skilled user may also fail to construct the query for retrieving data. Suppose if we use all and between the keywords, then sometimes we will get the empty result cells. Suppose if you use or between the keywords, and it may result too many result. It may give too many results. So even the very skilled programmer also confused to construct the query to get the only required data. So these are the drawbacks of Boolean keyword model. To overcome the drawback of Boolean keyword model, the information retrieval system introduced the IR scoring function, IR system evaluation, IR refinement, the PageRank algorithm and the hits algorithm, after that the question answering. So these are the methods which are used to overcome the drawback of the previous system. Okay. Let us see all those things one by one. IR scoring function. Okay. The IR scoring function that takes a document and query. Okay. Document and query, that is the document which will be retrieved by using this particular query. Okay. After entering this query, this will return a numeric score. Numeric score means when we enter the query, that will return more number of documents. For all the documents, the numeric score will be assigned, and the document which is more relevant to this particular query, that will get the highest score. That is, the first document will get highest score. Okay, so this is called as IR scoring function. Here the BM25 scoring function, here the score is linear weighted combination of scores. Okay. So linear weighted combination of score will be given for all the documents based on the words which are used to create the query. Okay, the words are otherwise called as keywords. Keywords to construct the query, and the three factors which will affect the query term. Right, what are the three factors? The first one is the frequency with which the query term appears in the document. Okay, the frequency with which the query term appears in the document. Let us take one example. Farming in Kansas. Farming in Kansas is a query. So from this, which term will get highest score? Farming will get highest score. Right? This is the first one. And second one, the inverse document frequency of the term, which are otherwise called as IDF. Okay, inverse document frequency. Let us take this query again, farming in Kansas. Here the word in will appear in almost all the documents, and in almost all the sentences we can find this in. That means the frequency of appearance of in is very high, high document frequency. Hence, low inverse document frequency will be assigned to this in, and thus it is not important as a query when compared to farming and Kansas. So we have to take the keywords only farming and Kansas, not this in. Okay, from this query. Okay, farming Kansas. And when come to third one, the length of the document. Okay, see which document will be displayed, either the infinitive word document or limited word document. Okay, here the most appropriate result is the short document that mentioned all the keywords. Okay, the short document which contains all the keywords of query, that will be the very better candidate when compared to a million word document. Okay. The IR system evaluation. To measure the information retrieval effectiveness. Okay, for this effectiveness, a standard way we need to follow for this, there is a test collection. The test collection consists of, first one is a document collection, that is a repository which consists of the document, and second one is there should be a query that should extract the required document from the repository, and third one, the relevance judgment should be there, that is if the query we post to this repository, the document should be either relevant or non-relevant. Okay, that means for each query document pair, there should be a binary assessment whether this is relevant or non-relevant, right? And next one, the system is given a set of queries. a system is given as a set of queries and result sets are stored here. And two measurements here we are using, first one is recall and second one is precision. When come to precision, it measures the proportion of documents in the result set that are actually relevant. Okay, that is true positive, that are actually relevant, precision. And when come to recall, it measures the proportion of all relevant document in the collection that are result set. So all the result set will be stored here. So two measures are we are using. Let us see these two with an example. So the example contains 100 document in a data set. Okay, the data set contains 100 document. By using a single query, we have to retrieve the relevant information from the data. Hence, we will store the result set also. Okay, and here the table which gives the category of the result set, right? The first one is in the result set and relevant is 30. So the 30 is true positive, okay. And the second one is in the result set not relevant, So and the third one is not in result set but relevant, and the fourth one is not in result set not relevant. Okay, so these are the categories of result we have retrieved from by using this query. Okay, now let us compute the precision. So when precision, we have to take these data, right? Okay, that is 30, that is true positive, divided by 30 plus 10. So 10 is the data which is available but not in relevant. Okay, so the total is, the result is 0.75, the precision is 0.75, and when false positive, 1 minus 0.75, that is equal to 0.25. So this is false positive rate. When come to recall, see, for recall we have to take only the relevant data, okay. Here 30 divided by 30 plus 20, which is equal to 0.06. So the recall rate is 0.06. When compute the false negative, the rate is 1 minus 0.60, then this is 0.40. Okay, the false negative is 0.40. So the precision 0.75, false positive 0.25, recall 0.60, and false negative is 0.40. If the document size is very small, then we can easily compute the precision and recall. But if the document size is, the collection is very large, huge volume of document collection in the repository, then it is somewhat difficult to compute the precision and recall. Okay, for example, if we take World Wide Web, there is a very huge volume of data will be there. So it is very difficult to compute all those things, the precision and recall. Okay, because there is no easy way to examine every page of web. Okay, the relevance or not relevance, and for this we have to estimate either by using sampling, or ignore recall completely and just judge the precision. Okay, which data we have actually retrieved from by using this query. Okay, here refinement. There are many possible refinement algorithms there which are implemented for web browser, and the web browser, that is the search engines, are continuously updating their algorithms, and they discover new approaches with respect to growth of web and changes in the web. And a simple document length normalization scheme, that is a simple document length normalization scheme which will be very much helpful for short document, but it is not suitable for the long documents. Okay, that is, we cannot fix the size of document, right? So they propose a pivoted document length, normalization scheme. See, if we implement this particular scheme, the shorter document will get boosted and the longer will get some penalty. Okay, so we cannot fix the pivoted length of document for normalization. And here the second one is BM25 scoring function. Okay, this used for a word model which treats all words completely independent, right? See, the words coach is closely related to both coaches and sofa, isn't it? Many the information retrieval system attempt to account for these corrections by using stemming algorithms. The stemming algorithm, this will remove ing from the word. Okay, but we cannot completely remove ing from all the words. For example, some words itself is having ing. For example, ring. We cannot remove ing from this word, isn't it? So this is the problem of implementing stemming algorithm. Okay, and another one is we have to implement the stemming algorithm only in English language. This is not suitable for all other languages. The next one is recognize synonyms. Synonyms, for example, instead of coach we can use sofa, isn't it? Both are same only. But suppose if we want to search team coach in by using a query, here we are searching only the football player, not the sofas, right? Because this coach is a noun which is related to a person here, and some words are same meaning, that is, two words may have same meaning. To avoid such confusions, these words should be combined to evaluate the original meaning of the sentence, right? Sometimes the related words not synonym also play important role in the ranking. Okay, uh, for example, suppose if we want to search coach in the web, the related words like weather, wooden, modern, that is weather coach, wooden coach, modern coach, should also comes to our result set. Next one is metadata. That is, by using metadata also we can improve the information retrieval system, okay, which are outside of the text document. That is, by using the keywords and the publication data, we can rank the resultant data set. And the hyperlinks between the documents also very much helpful for source of information. Okay, by using this also we can rank the resultant data set. The PageRank algorithm. PageRank algorithm is actually introduced by Google in the year 1997 by one of its founder, Larry Page. So his name is given for this algorithm, PageRank algorithm. And the PageRank algorithm uses anchor text. Anchor text means an underlined text in a hyperlink. Okay, underline text in a hyperlink, and this anchor text is used to index a page, right? So the page rank is a way of measuring the importance of website pages. This is important. Okay, so according to Google, a page rank works by counting the number and quality of the link. Okay, counting the number and quality of a link to a page to determine a rough estimate of how important the website is. For this purpose we can use the PageRank algorithm. Okay, and the underlying assumption is that more important websites are likely to receive more links from other websites. Okay, that means the more important websites will come on top of the index. okay, and the less important will come in the bottom of the pages. Okay, so on based on the importance of website, the rank will be assigned. The HITS algorithm, which is otherwise called as hyperlink induced topic search algorithm, it is a link analysis algorithm that rates the web pages. Okay, that means the algorithm is used to web link structure to discover and rank the web pages relevant for particular search. So based on the query which are given in the text box, the websites which are relevant to this query will be ranked and displayed. Okay, here the HITS uses hubs and authorities. Okay, these are important. Hubs and authorities to define recursive relationship between the web pages. Accordingly, the rank will be given. Okay, here a given query to the search engine that sets highly relevant web pages are called as routes. Okay, highly relevant web pages are called as routes and they are authorities of the given query, and the point to page in the route is called as hub. Uh, Question answering. The information retrieval is a task of finding documents that are relevant to the query. That is, in the query box we have to type the query. The query may be a question or topic or concept. Accordingly, we will get the set of document list, okay, which are relevant to this particular query. But when come to question answering, this is somewhat different. Here the query is really a question. Okay, the query is really a question and answer is not a ranked list here. Okay, but a short response, this may be a sentence or a simple phrase, that means a simple paragraph of text. Okay, so this is called as question answering. The question answering, the query should be in the form of question and answer may be a very short response, that is a single sentence or a small paragraph of sentences. In question answering, Ask MSR system is a web-based question answering system. It is based on intuition, that is based on the perception. Most questions will be answered many times in the web. And the question answering should be a thought of problems in precision, not recall. That means if we post a query, it will immediately give an answer. In the short form. It will not give all the documents which are related to this query. Okay, that means we don't have a deal with all different ways that an answer might be phrased, but only find one of them. That means if we give one single query, that will give one suitable answer for this query, that's all. So far we have seen the information retrieval system from third unit, and this topic we have discussed the basic information retrieval system with an diagram and the characteristics of IR. After that we have seen one method called as Boolean keyword model, and also we have seen the disadvantage of Boolean keyword model and some of the other methods to refine this IR. Those are IR scoring function, IR system evaluation, IR refinements, PageRank algorithm, HITS algorithm and question answering. And this is another important topic from third unit. You can expect one 10 mark question or 5 mark question from this topic. And the next class we will see another important topic from third unit. Thank you.